Hey, welcome back. Now let us write the print list function that's going to print the content of each node. We have two print lists there. One is print list that's going to print the content of each node. That means the data part of each node. And the print list details, the other function, it's going to print the linked list in details. That includes the address of each node, the content of the data field, as well as the content of the next pointer field. That will make the whole linked list visible to you. It will be much comprehensive to understand the linked list if you have the linked list parts displayed there in the console. So we'll be doing that later on. First of all, let us write the print list. That's a simple one. So we'll start printing the content of each node from the very first node. So we need a pointer there that's going to point to the first node, and you can get the address of the first node from the head pointer. Prior to doing that, what you need is to check whether the linked list is empty or not. So let's do that first. If lstptr, we know that if the node count is 0, then obviously the linked list is empty. Or you can check whether the head is null or not. So if listptr arrow node count, I'm checking the node count. You can do that by checking the linked list head as well. Then the linked list is obviously empty. So linked list is empty, and we must return from this function because the linked list is empty. We do not need to go forward. Otherwise, if the linked list is not empty, then we need to start printing the data part of each node from the very first node, and we need to get the address of the first node in a node pointer. So I'm having this current as the node pointer there, you can see. So we need to fetch the address of the first node from the head, and that we can do by using the listptr, because the listptr is pointing to the list object that contains the head. So we get the address of the first node from the head of this linked list into this current pointer, and this current pointer is right now pointing to the first node. Now we need to iterate, and I'm using a while loop for this purpose. So as long as the current is not equals null, the current will be null when it is actually there at the end of the list, because you can remember that the next field of the last node always contains the null. So when we'll be picking up that next field from the last node, the current will be assigned to null. So now the current is not null. Okay, we are entering into the loop, and then what we'll do, we'll be printing the content of this node that is being pointed by the current right now. If that is the first node, then we are printing the content of the first node. Then we need to move to the next node. Now in order to move to the next node, we need the address of the next node, and that's there in this node in the next pointer field. So current equals current arrow next, just jumping to the next node. So current arrow next is the address of the next node, and we are picking that and we are assigning that to current itself. So the current is now going or moving to the next node. Okay, so in this way it will print the content of the current node, and then it will move to the next node until and unless it is getting null there in the next field of the node. So if the null is there, that means we have printed all the nodes content and we are done. So in that case, the loop will terminate and we are coming out of the while loop. So let me just explain this using a figure there. I'll be drawing a linked list and I'll try run this so that you can understand it better. Okay, let's do that. Okay, just consider this situation. We have a linked list there. As you can see, the list is at address 500, the list object that contains the head, tail, and the node count. Node count is 3 because there are 3 nodes in this linked list currently. The list object is there at 500, and we pass that list address to this list pointer in the print function. So the list pointer is 500, listptr is 500, and that's pointing to this list object in the main. Now there are 3 nodes. The address of the first node is 1000, and you can see that it's there in the head. So head is pointing to this first node. Let us consider some value there. So 10 is the data content of this node, and 20 is that for the second, and 30 is that for the third. Okay, so the head is right now pointing to the first node. As you can see that the address of the first node, that's 1000, is assigned there in head, and the tail contains 3000. That's the address of the last node, and each node contains the address of the immediate next node. 2000 is the address of the second node, and that's there in the next field of the first node. So now in order to print the list, we will actually call this function print list, and we'll pass the address of this list object to that list pointer there here. So list pointer is pointing to this list object, and you will be checking whether the node count is 0 or not. No, this is not 0, that's 3. So we come here and we get the address of the first node from the head. So lstptr arrowhead is 1000. That's assigned to this current pointer. So the current, let me draw that. That's right now 1000. So this pointer is pointing to the first node. And we are here with the while loop now. The while loop will check whether the current is not null. Yes, that is not null. 1000 not equals null is correct. That's true. It will enter into the while loop. That's the first time. And you see that we are printing the current arrow data. That's 10. That will be printed first. Current arrow data is 10. That will be printed. And then at line number 133, we are just assigning the content of the next pointer field in this node to the current. So current arrow next is right now 2000. You can see that. Current arrow next is 2000, and that we are assigning here at line number 133 to the current itself. So the current was 1000 and that will be 2000 now. So let me just update that. So current is now 2000. So it's not going to point the first node anymore. It's going to point the second node. So we are actually jumping to the second node. And again, we are iterating back in the while. You can see that. And again, we are checking here current is 2000, not equals null. That's true. Again, it will come inside the while loop. At line 132, it will print the current arrow data. That's 20. 20 will be printed next. Then again, we are assigning the content of next field, current arrow next, to current itself. Now, current arrow next this time is 3000. So that's going to be assigned to current. So current will be updated to 3000. So current will jump to the next node. So I'm updating that. So this is 3000 now, not anymore 2000. So it will be pointing to the third node. So now the current is here. It is pointing to the third node. Now again, we are iterating back in the while. Current not equals null. That's true because current is 3000. Again, we are coming inside of the while loop, printing the current arrow data. That's 30. So 30 will be printed next. And then again, what we are doing, we are assigning the next of this current node to the current. So next of this current node, current arrow next, you can see that this is null this time because we do not have any more node there left. So null will be assigned to current. Let me update that now. So we have null there. So now if we assign null to the current, current will be null and will not be pointing to anyone. So this is null here. And if we iterate back now in the while loop, you can see that null not equals null, that's false. It will come out of the while loop and the loop terminates. And we have these contents printed on the console. So this is how we can iterate through the linked list and we can print the content of each node there in the console. And this will be the same technique. The technique will be same when you are going to iterate through the linked list, whatever the purpose is. If you want to search something in the linked list, you need to iterate in the same way. Okay, you can use a for loop instead of a while loop. That's up to you. That's your choice. So current equal current arrow next, that may be tricky at a first glance, but that is how we are jumping to the next node. We are utilizing the content of the next pointer field there that is holding the address of the next node, and we are going to the next node. So I'll be writing the print list details in the next lecture, where we'll be printing the content of head, the content of tail, and the address of each node, the data part of node, and the next field of each node. And that will make the whole list visible, okay, as I said earlier. So let's move on to the next lecture. Thank you very much.